Here is the transformation foldable. I just cut around the outside, cut down the sides, I cut off the top and the bottom, and then you're just going to fold the doors into the middle. You can cut each one of these doors if you want to. Vertical shift up. Here's our main function, x squared. A vertical shift up means you're talking about the y-axis. And so here I'm wanting to shift up 2. That's on the y-axis. So that means x, and I would be adding 2 to my y value. All my y values are being added by 2. 0 plus 2 is 2. Here I have y is 1. So 1 plus 2 is 3. Same thing on this side. 1 plus 2 is 3. And I can see my parabola here. This would be at 4. So 4 plus 3 would be 7. I'm not going to put that one on here, but here is the parabola shifted vertically 2 units. Vertically shifting down, we see minus k, and I'm shifting down by 1. Here's my square root. The square root function, it's not with the x, it's on the outside, the k value, so that means that all of my y values will be shifted down 1. So we have 0 for y, that means I'm going to be shifted down to 1. Here is another point I'm picking, it's at 1, so it'll be shifted down to 0. And another point right here, this is at 2, and I'm shifting it down 1. There is the square root function being shifted down 1. Horizontally shifting has to do with the x. That is the x-axis. Here I would like to shift all of my units. Now be careful here because of the minus sign. I'm not going to -2, but I'm actually shifting to +2. So all of my x's I'll be adding 2. Here is an x. It's at 0, so I'm going to add 2. Here is an x at 1. I'm going to add 2. 1, 2. There's 1 right here. I'm going to add 2. 1, 2. Starting to see that V shape. Let's go for one more. Let's go here. I pick this point and shift 2. 1, 2. 1, 2. I shifted 2 in the positive direction. I added 2 to all my x values. Same thing with shifting left. That means I'm going to be subtracting 2, not adding 2, but subtracting 2. All of my x values will be subtracted by 2. Subtract 2 from my x over 2. I take this point, move it over 2, 1, 2. I'm going to take this, move it over 2, 1, 2. And one more. Let's go with this one. 1, 2. And 1, 2. I can see that my parabola has been shifted to the left 2 units. I subtracted 2 from all my x values. We have been working on vertical and horizontal shifts that you should be familiar with. And now we're moving on to other types of transformations like reflections, stretches, shrinks. Okay. Reflecting over the x-axis. To reflect over the x-axis, that means you are going to negate all your y values. I'm reflecting over the x-axis, therefore I'm changing the sign on all my y values. This would still be the same. If y is 1, then -1 will be in the reflection. If y is 2, then -2 would be in the reflection. I have just reflected over the x-axis. Can you take a guess what we're going to do to reflect over the y-axis? That means that I would have to negate all the x terms. That means all my x's will be negated to reflect over the y-axis. This one's going to stay the same. Here I have that x is 1, so -1 for x. X is 4, so -4 would be in the reflection. This time we reflected over the y-axis. To reflect over the x-axis, we negate all of the y values. To reflect over the y-axis, we negate all of the x values. Vertical stretch, vertical, has to do with the y-axis, has to do with the y variable then. Here is my function, the absolute value of x. Here it is at the origin. And I am going to vertically stretch this by 2. It's being multiplied to the function, not to the x. The 2 is being multiplied to the function. So that means that we're multiplying to the y value. That means that we would have x, and then we're going to multiply 2 to all of the y values to get a vertical stretch, stretching it out. So I'm going to multiply 2 to all my y values. When x is 0, we have that y is 0, and it's still going to be 0. When x is 1, we have that y is 1, but when I multiply 2 to 1, I get 2. And we'll go for 2. We have 2, 2. So when I multiply 2 to my y value, I get 4. We have 0, 0. Here is 1 times 2 is 2. And then 2 times 2 is 4. And we can see that it's vertically stretching up. This would also be true on the negative side. The absolute value of -1 is 1. And then when I multiply 2 to it, I still get 2. But -1 is also at 2. And that would be true for at 2, we would get 4. So here we can see the absolute value has been vertically stretched. It's being stretched, which making it skinnier. It has been vertically stretched by 2. What would a shrink look like then? If this is stretching up, then that would mean a shrink would be going out, going further away from the y-axis. This got closer to the y-axis. A shrink will be laying down more, further away from the y. All right, here's a cubic. We haven't done too many polynomials, but we're getting there. All right, so I have a vertical shrink. That means that you're multiplying to the function, but this time it's a number between 0 and 1. That's a fraction. So a shrink would be when you're multiplying a fraction to the function. So here we see that nothing for x, but I'm multiplying to the function y, 1/4 of my y's. All right, so 0, 0 would still be there. 1/4 all my y's. Well, here's 1. That means at 1/4 would be down here. It's laying down, and that would be true as well over here. It would be laying down more. You can make a table of values for all of these. Let's go with all right, x is 2. 2 cubed is 8. And now when I multiply that by 1/4, we get 2. And that would be true for -2 as well. -2, we get -8. And then when I quarter that, I get -2. And so a vertical shrink means it's been flattened out a little bit. It's gone out further away from the y-axis. It's been shrunk down. A vertical shrink. It was at 1 and it shrunk down to 1/4. It was at 8 and it shrunk down to 2. Vertical shrink versus a vertical stretch. Those are pretty straightforward. Unfortunately, as it is when you have the shift on the x-axis, you always have to think of the opposite for a shift left and right. That's going to be true for the stretch as well. We're talking about horizontal. We're talking about the x, which means you've kind of got to think about it the opposite. All right. So we're looking for a horizontal stretch. We want a horizontal stretch, which is really the same thing as a vertical shrink. These are the same, as well as these two. All right, so here we want to do a half x. When I substitute that in, you are squaring that. You'd have parentheses here, and you'd put a half x in there, and you would get a half times a half is 1/4 x squared. So a horizontal stretch is when you have a fraction and you're multiplying it to the x. Here you were multiplying it to the y value. F of x means y. So really it's a times y. You're multiplying your a to the y value. Here you're multiplying your a directly to the x. When x is 1, we get 1 times 1/4 is 1/4. Coming down here, and that would be true for -1 as well. And when we have x is 2, we get 2 squared is 4, and then 1/4 of 4 would be 1. So at 2, it's 1. At -2, that would also be true. We can see here that a horizontal stretch is the same thing as a vertical shrink. So the horizontal stretch is being stretched out this way, and you're multiplying it directly to the x. Directly to the x versus to the y. A horizontal shrink is when a is greater than 1. And that means we're going to be multiplying to the x. So 0, 0, when x is 1, we get 1 times 4 is 4, and the absolute value of 4 is 4. That would be true for -1 as well. -1 times 4 is -4, and the absolute value of -4 is 4. And so we can see here that we've had a horizontal shrink. Horizontal is going this way, and it has shrunk. So we have a horizontal stretch and a horizontal shrink. 1.6, example 1, vertical translations. Describe how the graph of y equals the absolute value of x can be transformed to the graph of the given equation. Here we see, now we just need to keep in mind that the general equation is always y equals x minus h plus k. We also need to take into consideration things that are in front of the x or in front of the function itself. You could have a number up front, which is being multiplied to the function. That means you're multiplying to y. Or you could have it on the inside, call it bx minus h plus k. So we're always looking for hk. H is a horizontal shift. K is a vertical shift up and down. We have a out front, which is being multiplied to the entire function y. And then we have when you're multiplying to the x for a shrink or a stretch on the x versus multiplying to the entire function, stretching and shrinking vertically. All right, so if I can keep that in mind all the time, then I'll be able to do any function from the parent function. Here, this fits the k. That means that we are shifting up and down. So I would say that there is a vertical shift down 4 units. At the origin. And then we shifted down 4 units. Next, we have a horizontal shift. The x-axis, we're talking about the h here. And remember, it's the opposite of what you're seeing here. It is not to the right 2 units, but to the left 2 units. Left 2 units. So here I am at the origin. And then I'm going to the left 2 units. To -2. Example 2, finding equations for translations. So we have the first graph is x cubed in the red, and a vertical or horizontal translation. Write an equation for y2 shown in each graph. So we have y1 is x cubed. Here, the blue is going to be our y2, and we can see that it's been shifted down. It was here, and it went down 1, 2, 3 units. So we just shifted down 3 units. y2 would be x cubed minus 3 to shift on the y-axis. Here we are at the origin, and we are shifting to the left 1, 2 units. We are shifting left. So that is on the x. Shifting left 2 units means x plus 2. We're shifting left. It's not +2 we're going to, but -2. Here, we are shifting 1, 2, 3 units to the right. So y2, we're shifting on the x-axis. That has to do with the x. And we're going to +3. That means x minus 3. We've talked about reflections. If I'm reflecting across the x-axis, that means I need to negate my y values. If I am reflecting across the y-axis, that means I need to negate my x values. That's as easy as that. Okay, so for example 3, I did draw the main graph using my graphing calculator. I just picked some points and I made the curve for both of them. Reflecting across the x-axis, if I want to reflect across the x, that means I need to negate the y value. I need to negate the entire function. So if I put a negative out front of the function, that means that I will need to distribute that negative. Let's say it was a -1, right? You're going to be multiplying to the numerator only. So that would be -1/1, and you're distributing that negative. We get negative times 5x is -5x, and then a negative times a negative is a +9. The denominator stays the same. A lot of times they don't like to see the negative out front leading, so you might see something like this. So just switching your values and saying 9 minus 5x. I am not that picky of a teacher. I would accept either one of these. Okay, so there is the equation. I will need to negate all of my y values to reflect across the x. So I'm going to use these specific points that I have here, and I'm going to change them. This would be at 3, -0.5. That's 0.5 for the y value, so that means -0.5. So here, -0.5. And again, we know that when we're reflecting across a line, they're equal distance and they're perpendicular to each other. We would know that this point would be here. You have 1, 1, that means you would have 1, negative 1. So that means 1, 1 would be in here. 0, negative 3, so 0, 3. Negative 3, negative 2, so negative 3, positive 2. We are reflecting across the x-axis. So that means we're coming in from here, crossing over, coming up, coming down, and writing there. Y equals negative f of x, and y equals f of x. I could have used my equation, found some points, but it's just as easy to be able to reflect and using the picture. Okay, reflecting across the y-axis. That means that we are going to negate all of our x values. Reflecting across the y-axis means negating x. So here is the function algebraically. I am negating all of the x values. F of negative x equals 5 times negative x, and then negative x squared. I substituted in a negative x for all of the x's. F of negative x equals negative 5x minus 9 over negative x times negative x is x squared plus 3. That's algebraically. And now graphically, I'm going to switch all of my x values. I'm going to negate the signs on them. If I have 3.5, that means that I would have negative 3. 1, 2, 3. Negative 3.5. 1, negative 1. Then I have negative 1, negative 1. This would still be the same. 0 stays 0. And then here, negative 3, 2, so 3, negative 2. 3, negative 2. Okay, so this is going out. That means I'll be coming in, going down. And I would still be going down to here. That did not change. Then going out. And riding along here. Actually, I need to have a little dip down here. I had this point, so I should have this point. It should be coming down and going up. Reflecting those, reflecting these two, reflecting these two, and these two. Okay. This would be f of negative x, and this f of x. Example 4. Prove that the graph of an even function remains unchanged when it is reflected across the y-axis. An even function, the definition of an even function is when I substitute in negative x, I get back f of x. So here, let's look at an example to see if we've picked out an even function. Is f of x equals x squared even? Is it? Let's check to see if it's even. If it is, then I will be using it in my example. We know that we have to substitute in negative x for the x values, and we simplify. Negative x times negative x is x squared. I got back what I started with. I see here that when I substitute in f of negative x, I get back f of x, which means it's even. I'm going to use the function then, x squared, because I know it's an even function. Here is x squared at the origin. Reflecting across the y-axis means that we need to negate all of our x values. 1 would be negative 1. 2 becomes negative 2, 4. And of course, we have 0, 0 at the origin. So if I was to take these points and I was to negate them, they would land over here. If I was to take this side of the function and reflect it over the y-axis, I would get these points. It is the same function. Even functions remain unchanged when reflecting across the y-axis. Example 5, find the equations for stretches and shrinks. Let C1 be the curve defined by y1 equals f of x equals x cubed minus 16x. Find the equations for the following non-rigid transformations. All right, so here's C1. C2 is a vertical stretch of C1 by a factor of 3. A vertical stretch. Does that have to do with the y variable or the x variable? That has to do with the y variable. All right, A, we would say that C2 equals a vertical stretch means on the y, so we're multiplying to the function. That would mean 3 times f of x. We're multiplying 3 to the function. We're multiplying 3 to the y value. F of x means y. That means we have 3 times x cubed minus 16x. We get 3x cubed minus 48x. That would be C2. All right, this book has a little bit different of a definition than the one that I use. C3 is a horizontal shrink by a factor of a half. A horizontal shrink. Remember that when you're dealing with the x. A horizontal shrink, we're talking about the x variable, and it's not always what we see, always the opposite of what we're thinking. It has to do with the x. The y is straight up. Multiply 3 of the function, boom. You've got your vertical stretch of 3. I am going to use the book's definition for shrink. We have that for a horizontal shrink, if I had the function y equals f of x divided by c. And so here, c is a half by a factor of a half. So I get f of x divided by a half. And with fractions, we know that if I have x divided by a half, that means to flip and multiply. So that's x times 2 over 1, which is just 2x. You need to flip the second fraction and multiply. That's how you divide fractions, flip and multiply. Here we can see that now it's starting to line up with the way that the foldable is saying. To be a factor of a half, we're actually multiplying the x values by 2. It's that opposite thinking. So we have y equals f of 2x. This is all right. So multiplying by 2 on the x is actually a factor. It's a shrink of a half. It's that opposite way of thinking. We have then we're multiplying 2 to all of the x's. So that would be that C3 would be then multiplying 2 to the x cubed minus 16 times 2x, multiplying 2 to the x. We get 2 cubed is 8, and then x cubed minus 32x. If we have time, we will go back and talk more about this. If you're wanting to fill this in, you could just use your graphing calculator. We're going to keep going here. Example 6, combining transformations in order. We're going to see here why order is important. When you're doing transformations, it's similar to thinking about PEMDAS. I say that it's similar because when you are required to do it by order, you do want to do multiplying, any kind of multiplying and dividing first, and then you're shifting left and right and up and down, adding and subtracting. So it's important to make sure that you're doing reflections, stretches, shrinks before your horizontal and vertical shifts. We're going to see here why order is important. All right, A says that we're going to take x squared and we're going to do the following transformations in order of how they've written them. We're going to find the equation of the graph that results. So first thing they want us to do is to horizontally shift 2 units. I would just like to keep this in mind. Those 4 letters can be used in every function. All right, so horizontally, going horizontal on the x then, 2 units to the right. 2 units to the right. So is it x plus 2 or x minus 2? There is 2 units to the right. And now a vertical stretch. Vertical stretch. That's on the y. That means the entire function. You're not multiplying to the x. You're multiplying to y, the entire function. That means I'd have it out front here to the whole function. Not just multiplying to the x. It's multiplying to the entire function. That would be multiplying to the y. And then a vertical translation up 5 units. So we multiplied out front of the function for a vertical stretch. And now we're going to do a vertical translation, our k, up and down. We're going up 5 units. So that would be y equals 3 times x minus 2 squared plus 5. Now we need to find this function so we can compare it to the next function we're going to do. That means expanding this out. So we have y equals 3 times x minus 2 times x minus 2. And again, I would have used the shortcut here, but I know that you're not really ready for it yet. So I'm starting here with my multiplying. We have 3 times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. And negative 2 times negative 2 is positive 4. Multiply by the 3. And I need to clean this up on the inside. Negative 2x, negative 2x. Now I'm ready to distribute. We have 3x squared minus 12x plus 12 plus 5. Our final answer then would be 3x squared minus 12x plus 17. B says to apply the transformations in A in the opposite order. So we're going from the bottom up this time. Vertical translation up 5 units. So we're starting with y equals x squared, and we're translating up 5 units, plus 5. Vertical stretch, multiplying vertical to the y. That means y equals 3 times the function. And now a horizontal shift 2 units on the x. So we have y equals 3. I'm going to make these square brackets. All right, so we have 3 is being multiplied to the shift, and we're going at plus 5. All right, now we're going to expand this out. This time I am going to use the shortcut on the binomial squared. Instead of writing it with 2 sets of parentheses, I'm going to use the shortcut and multiplying right from here. So I would have 3 out front still. The first term is x times x is x squared. Remember, the middle term is 2 times the first term times the second term, because there are always 2 terms that are the same. So 2 times x is 2x times negative 2 is negative 4x. Plus 5. And finish. We get y equals 3x squared minus 12x plus 15. We can see here that when we apply the order in 2 different directions, we don't get the same function. That was trying to prove that to you. From now on, when you're asked to do transformations, no matter which order they list them in, you need to do the transformations that are about multiplying and dividing, and then doing your shift with h and k at the end. You want to apply anything that is being done to the y value, to the x value. A reflection would also be that as well. Save your hk for the end on adding and subtracting. Otherwise, you can see you're not going to get the same function. All right. I drew the figure from 1.78, going from 2 to 2 at kind of a curve, and then a straight line down to 4. The graph of f of x is shown in the figure 1.78. Determine the graph of the composition by showing the effects of the sequence of the transformation. So I have this function. Here it is at the origin. Now I want to do some transformations on it. What transformations do we have? We see that we have 2 is being multiplied to the function. That means 2 is being multiplied to the y value. If it was the x value, then it would be on the inside with the x. So we know 2 is being multiplied to the function y. We see there's a horizontal shift on x, and there is a vertical shift on y. I'm going to save my horizontal and vertical shift to the end. I'm going to start with my stretch. So the first one that we're doing is we are multiplying 2 to the y value. That would be a vertical stretch. So here's my y value. My y value is at 2. That means I'm going to be multiplying 2 to my y value. So I get 0, 4. 1, 2, 3, 4. So I would still have this coming up like this at a curve, and then it would be a straight line going down. Okay, there's the first one. Now using this one, I'm continuing on. I'm not going to go back to the original. I am going to be using this one in the next one. The next thing that I would like to do is I am going to do a shift on the x. That means I'm going -1 on the x. So I'm going to take all of these and move them over 1, all my x's. So my x is going to be -1, and my y stays the same. I'm going to subtract 1 from my x's. Keep my y the same. So I was here at 4. I'm going to subtract 1. Over here, I was at -2. That means I'll be shifting over 1. And I was at 4. I'll be shifting over 1. That means we have the curve coming up here. And then we have a straight line here. So it was stretched by a factor of 2, and then shifted by a factor of 1. The last thing to do would be to shift down 3 units. So I did my multiplying first, and then I worked on my adding and subtracting here with the HK going down 3. That means that all right, so we're using the previous graph. We're doing it in a sequence showing all of the transformations. We're using this one, and we're shifting all of our Y values down 3. I was at 4, and I'm going to shift it down 3 units. 1, 2, 3. We were at -3 and going down 3 units. 1, 2, 3. And here we were at 3, we're going down 3 units. So this is the curve. And then this is the straight line. And we can see the final result is here. Stretch it vertically. We shift it to the left horizontally, and then we shifted it down vertically. And that's how you do transformations, one at a time, making sure that you take care of any multiplying and dividing before you're doing the adding.